Hey, 6th grade. Okay, so, per the instructions in Sabbath, or I mean, it's in Wisdom, excuse me, you were to complete this on your day 1. And so we're going to talk about it. We're going to kind of go over the review. And if you read in Wisdom really closely, you would know you're supposed to watch this little short video in order to go for the review. So number 1, it tells you to write the letters of the correct answers on the lines at the left. So what I want you to do is correct this for a easy 100 and then take your assessment. It says you probably use the term heat many times a day. As an example, when you cook dinner, you heat your dinner on a hot stove. When you place a piece of cool metal in the sun, it's heated by the sun's energy. Why is the heat the correct term to use in these examples? Well, the correct answer is B. They show that heat flows from something warmer to something cooler. Okay? Heat is the thing that flows from warmer to cooler. Number 2 says in the paragraph below, select a word from each of the word banks correctly complete the sentences. It says the contents of a bucket were in a liquid state. Usually if you put something in a bucket, it's a liquid. Okay? If the contents were heated up enough, they would change to a gas state. Okay? We're talking about heat. So number 3 and 4, you're going to use this information. Okay? So he's talking about a mug of hot chocolate, how the heat flows to his hand, and then his hand, the heat from his hand flows to the ice cube. Okay? He also says he's got the ice cube going back to the hand, going back to the mug of hot chocolate. Okay, so it's a current. So looking over here, number 3, it said, what could Eric conclude about what happens when heat is added or removed from an object after he completed his test with the mug of hot chocolate? The correct answer here is A. It says arrow A shows, because it's talking about the mug of hot chocolate. Arrow A shows the direction heat flowed because the temperature of his hand increased as heat was absorbed by his hand. Okay? Number 4 says, what can Eric conclude about what happens when heat is added or removed from an object after he completed the test with the ice cube? Okay? Include which arrow best represents the direction of heat flow and which objects are absorbing or releasing it. So he's talking about the portion with his ice cube. So when we get to the ice cube, okay, so it says, first he places a mug of hot chocolate in his hand and records the temperature of the hot chocolate and the surface of his hand every 5 minutes for a total of 15 minutes. He repeats this procedure when investigating heat flow with an ice cube. Okay, so from his hand holding an ice cube, what happened to his hand? Right? His hand transferred heat energy to the ice cube, and the ice cube in turn also made his hand get cooler. Okay, very good. It went cooler. Okay, so the arrow that best represents that is probably arrow C. Okay, because remember, we're talking about heat and the direction heat flows. Heat is flowing to the ice cube, not away from the ice cube. Okay, so arrow C. So let's look here. It says write the letters of the correct answers on the lines at the left. So number 5 says when a boy and his friends arrive at a barbecue, they offer to help their friend cook. They place meat and vegetables from the refrigerator onto the hot grill. When the food is cooked and taken off the grill, it is at a much higher temperature than when it was before it was cooked. Which statements, meaning more than one, are true about the food? Choose the 2 that apply. So remember, heat flows from a hotter object to a cooler object. So The kinetic energy of the food particles increased, causing the food temperature to rise. Remember, kinetic energy and heat are directly there, they go hand in hand. The thermal energy of the food increased. So A and B are your correct answers because everything increased, nothing decreased there. Okay? So number 6. A student likes to attend football games, no matter how cold and snowy the weather becomes. She is going to a game on a very cold day and takes a hand warmer. She activates it and tucks it into the glove she is wearing. She holds her hands together, and before long her hands are warm. Which best describes how her hands were warmed? The correct answer is A. Heat, remember, is transferred by conduction. So that was back a couple note pages ago, resulting in an increase in kinetic energy. So heat transferred by conduction. Okay, remember convection is an oven. Convection is where heat is circulating around the stuff. Conduction is where it's directly touching it. Okay, so A is the correct answer for number 6. Number 7 has 2 answers. It says choose the 2 that apply. It says you are camping and it is time to build a campfire. You gather logs and stack them loosely, and then you add small twigs and leaves to make the fire easy to light. As you sit by the fire, the logs burn bright in the darkness and you feel the heat coming towards you. Which of these statements are true about the amount of energy transformed in a campfire? So, a law of conservation of energy applies to these transformations. Yes, A is one of them. Chemical energy in logs is lost during the transformation. No, chemical energy does occur, but it's not lost. C, the fire is hotter than the logs were, so energy is gained in this transformation. No, because remember, energy can neither be gained nor lost due to conservation of energy. And then D, the amount of heat and light energy released equals the amount of chemical energy that is burned. D is correct. A and D. Okay, and that was also in your Cornell notes if you wrote your notes accurately. Let's see, number 8. In the paragraph below, select a word from each of the word banks to correctly complete the sentences. It says, it's a great day at the beach and you're there for some fun and sun. One reason the day is so special is that the weather is so pleasant, sunny and warm. Energy from the sun warms the beach by... Okay, so it's transferring heat by radiation. The first one is transferring heat by radiation because remember, it's not touching it, right? It's not circulating it. It is by radiation. It's transferring the heat from the sun to the sand on the beach by radiation. Okay, that's an actual picture in your book. The breeze is warm enough to keep you warm. So breeze is our key word here, but it also keeps you from overheating. Ocean breezes move because energy is transferred by convection. Because remember, it's circulating around you, but it's not actually touching you. Then it says, when you lie down, I'm lying down on the sand, you can spread a beach towel down so that the sand will not make you too hot by transferring heat by conduction. So the last one's transferring heat by conduction because you're actually touching it. Conduction is touching. It conducts. Okay? Number 9. Energy can change in 2 different ways. It can undergo a transfer or it can undergo a transformation. For each of these examples of how energy is changed, write the correct answer in the blank. In photosynthesis, solar energy undergoes a... Now remember, you either choose transformation or transfer. So it undergoes a blank when it changes from light energy to chemical energy. So let's go on to the next one. Let's look at it. When the sun warms Earth's surface, thermal energy is blank to land and water. I will tell you the first one is transformation because you're changing from one to another. And this one is transferred because it's just being transferred from thermal energy is transferred from land or to the land and to the water. Okay. Number 10 says a student gets ready to go to school one day and he finds out that his car's battery is dead. The headlights will not come on and the car won't start. What transformations usually happen when the battery is active and the headlights come on? Okay, so a car battery, if you read in your text, it talks about it is a chemical. Okay, so car battery is where we start and then we turn on the lights and what has to happen between there. And so the correct answer is A, chemical to electrical, where we could contribute to light. Okay, so here we go. So here's your word bank. Jack's family is keeping track of the amount of money they pay for energy every month. They made changes to their home based on the thermal properties of various materials. They know that these changes will make their home more energy efficient. For each energy-saving method described, choose the term that best completes the sentence. It says the family replaced the windows in their home with double-hung windows. This helps because a layer of gas between the two panes of glass acts as a good insulator. Okay, it's an insulator. They added a layer of fiberglass to the outside of their metal hot water heater. This saves energy because the metal is a good conductor, but the fiberglass, okay, so the metal is a good conductor, but the fiberglass is a good insulator. Okay, again, another insulator. They wrapped all their copper pipes that carry hot water with layers of paper. Their energy bills will be less because the metal is a good conductor, but the paper is a good insulator. So all those are either conductors or insulators. Just saying. Okay. So here we go. Number 12. The front door of a home is made of steel. When it is warm outside, the door sticks and is difficult to open or close. When the weather is cool, the door does not stick. Which statement best explains the difference in the behavior of the door when the weather is warm compared to when it is cool? So this also happens with railroad tracks. And if you'll notice, on really, really hot days, that's when you see it the most. If you look down the railroad tracks, they almost look crooked. Okay, they almost look like they're bowing out or bowing up or something like that. And what happens is when they are heated up, the metal actually expands, and so it takes up more space. Okay, and so with heat they expand, the metal does, and with cooler temperatures they contract, which would explain why the door sticks, a steel door, because it's expanding, and then when it's cold it contracts again. And so the answer to number 12 is D. Okay, because it's an increase in kinetic energy, and it contracts when it's cooler because that's a decrease in kinetic energy. Now, this is all going back to stuff we've learned previous too, because we're going back to kinetic and potential energy. Number 13, the correct answer is B. Okay, the particles in the floor increase in thermal energy in warm weather. Okay, so 13 is B, because it's kind of by the same token. 14, the two correct answers are A and D. Number 15, you're going to have to kind of do that on your own. Okay, you're gonna go energy change equals mass times specific heat times temperature change. Okay, and this was something that you should write down. So this is the specific heat of those metals. And so notice you have the mass here for 15. Okay, so you're talking about specific heat. You're talking about temperature change. So you want to know about this. Now remember, spacecraft, when it goes to enter back into Earth's atmosphere, it gets, or even leave Earth's atmosphere, it's going so fast, it gets so hot. Okay, so you have to be very, very careful here and explain very well why you think what you think there. And then number 16. Okay, you have another word bank. It says Megan is baking cookies. Oh, chemical change. When she turns the oven on, she notices that the heating coils in the back of the oven start to glow orange. As she opens the oven to place the cookie sheet on the oven rack, she can feel the warmth from the oven. She watches the cookies puff up and turn golden brown. Read the paragraph that describes energy as Megan bakes. In the paragraph below, select a word from each of the word banks to correctly complete the sentences. Baking cookies in the oven is an example of how energy is conserved, saved, made, created. Electrical energy is blank to blank. So electrical energy Okay, then thermal energy either blank from one object to another as it is transferred of blank into a different form as it is transferred. So think about those. That is actually straight from your text that you read. Straight from it. I'm going to give you just a second to think about that. Okay, so baking cookies in the oven is an example of how energy is conserved. Electrical energy is transformed to light and thermal energy of the coils. Thermal energy either moves from one object to another as it is transferred, and that should say or, not of, or it changes into a different form as it is transferred. Okay, so changes, moves. This is light and thermal energy of the coils. Okay, this is transformed, and this is conserved. So, to recap, number 1 is B. Number 2 is liquid and gas. Number 3 is A. Number 4, remember arrow C represents the direction of heat flow. Okay, and so you need to talk about, you pretty much almost need to rewrite some of this in regards to the ice cube, and then tell me that C is the one that is the correct arrow. Okay, so then number 5 is A and B. Number 6 is A. Number 7 is A and D. Number 8, the first one is transferring heat by radiation. Second portion of it is transferred by convection, and then transferred by conduction is the third. Number 9 is transformation and then transferred. Number 10 is A. Number 11 is insulator, then conductor, then insulator, then conductor, then insulator. Number 12 is D. Number 13 is B. Number 14 is A and D. Number 15 we just discussed it at length. Number 16 is conserved, then transformed, then light and thermal energy of the coils, and then moves, and then changes. Hope you guys have a great day, and I will see you later.